Now, see here in this question here, we are going to discuss about the displacement current and conduction current. These are the two plates of the capacitor whose radius is given to you, that is 12 centimeter, and the separation between the plates is, that is 0.5 centimeter. Now, the capacitor is being charged by an external source. That battery is not shown here, but it is being charged by an external source. The charging current is constant and that is equal to 0.15 ampere. So, charging current is 0.15 ampere. You have to calculate the capacitance and the rate of charging of potential difference. So, we can write all details here. R is equal to 12 centimeter, charging current I is equal to 0.15 ampere. So, now we have to calculate over here, first is the capacitance and then the rate of charging, the potential charge of potential difference between the plates, and also we have to obtain displacement current. So, now we will find one by one all these things. So, we know the formula for capacitance, that is C is equal to, for the parallel plate capacitors, that is C is equal to A epsilon by D, and A can be written here pi r square into epsilon naught by D. R is given to you 12 centimeter, that is 12 into 10 raised to power minus 2 meter. Epsilon naught, so we can write here 3.14 into 12 into 10 raised to power minus 2 whole square into 8.85 into 10 raised to power minus 12 divided by value of the D is given to you 0.5 centimeter. So, that is 0.5 into 10 raised to power minus 2. When we solve it, we will be getting 80.1 picofarad, that is 80.1 into 10 raised to power 9 farad, that is taken as picofarad here. So, now the result is 80.1 picofarad, that can be written here 1 picofarad is equal to 10 raised to power minus 12 farad here. So, this is about the picofarad here. By solving this you can calculate. Now, we have to calculate the rate of potential difference or the charge of the potential difference between two plates. So, we know it, Q is equal to C into V. So, we can differentiate it, dq upon dt is equal to C into dV upon dt, where V is the potential difference. So, we have to calculate this. So, dV upon dt is equal to, that is here I upon C, and I is given to here 0.15 divided by 80.1 into 10 raised to power minus 12, and this can be written 1.87 into 10 raised to power 9 volt per second. So, that is about here the rate of change of potential between the plates. So, now we have to calculate displacement current. So, see here, what is the displacement current here? In this case we know it, or the displacement current we know it, ID is equal to epsilon naught d phi E upon dt, and we know it phi E is equal to electric field into area. So, we can write ID is equal to epsilon naught d upon dt E into A. So, epsilon naught A dE upon dt, that we can write about the displacement current. Now, we will go for this one, see what is dE upon dt here. So, we can write E is equal to here Q upon, that is A epsilon naught. If you differentiate it, you will be getting, in this case, dE upon dt is equal to A, that is 1 upon A epsilon naught dQ upon dt, and dQ upon dt is actually I. So, we can write here in this case dQ upon dE upon dt is equal to I upon here A epsilon naught. So, now we know ID. So, we have written ID is equal to already epsilon naught A dE upon dt. So, now we can put the value of dE upon dt, where ID is equal to epsilon naught A I upon A epsilon naught, cancel. So, here ID is equal to I, that is 0.15 ampere. So, actually I have shown here I is here, that is a conduction current. So, we have shown actually here the displacement current is equal to conduction current. So, the displacement current and conduction current both are equal.